Let's look at some properties of sequences. Suppose I have two sequences, a sub n and b sub n, and a sub n has a limit of L, and b sub n has a limit of k. If I were to add these two sequences, then the limit as n approaches infinity of the sum is the sum of the limits. If I were to multiply the two sequences, then that product, the limit as n approaches infinity of product, is the product of the limits. And clearly, if I can factor a c out of each term, then the limit as n approaches infinity of c times a is just c times that limit. The one you really have to check for is the limit as n approaches infinity. You have to make sure b sub n is never 0 and k is never 0, is not 0, so that when I do the limit of the quotient a sub n divided by b sub n, then that is just the quotient of the limits. Now there's an absolute value theorem that if the limit as n approaches infinity of the absolute value of the sequence goes to 0, then the sequence itself goes to 0. Now, let's look at the squeeze theorem for sequences. Suppose we have the limit as n approaches infinity of a sub n is equal to the limit as n approaches infinity of b sub n, and those both equal L. If there is an integer n such that my third sequence, c sub n, is squeezed between a sub n and b sub n for all n, then the limit as n approaches infinity of c sub n is equal to L. The beauty of this is you can ignore the first n integers. Now let's look at the sequence c sub n as minus 1 to the n divided by 1 factorial. I'm going to start this one by looking at the absolute value. The absolute value of c sub n, sequence of the absolute value of c sub n, is 1 over n factorial. Now, I don't know how to change this into a function because you usually need x to be continuous. But if I were to write out, so clearly if this sequence converges, then by the absolute value theorem, c sub n, sequence c sub n converges. So let me look at this one right here. Let me look at what n factorial is. N factorial is 1 times 2 times 3 times 4, dot, 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 all the way up to n. Now let me pick another function, one that I know converges nicely. And let's look at 2 to the n. I'm going to line these terms up, so it's 2 times 2 times 2 times 2, dot, 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 times 2. And we're going to have that n times. Now, I want you to look for any term, for the terms n equals 3 and greater, then we can rewrite this. So this is 2 times, and I'm just going to write it this way, 3 times 4 up to n, and 2 to the n is 4 times 2 times 2, 2. So let's look at these terms right here. So for n greater than 3, clearly 2 to the n is going to be less than n factorial. Therefore, 1 over n factorial is going to be less than 1 over 2 to the n. So, suppose I make my two sequences, a sub n equal 1 over 2 to the n, and b sub n equal minus 1 over 2 to the n. Now I could also make b sub n equal 0, that's fine. Then I know the limit as n approaches infinity of 1 over 2 to the n is equal to the limit as n approaches infinity of minus 1 over 2 to the n, and those are 0. Therefore, the limit as n approaches infinity of 1 over n factorial is 0. Therefore, the limit as n approaches infinity of negative 1 to the n divided by n factorial It's also equal to 0 by the squeeze theorem.